Hey, Talking Life Math and History, and we are going to take a look at angle side theorems. So in this video, we've learned a lot about triangles. There are many ways to prove that triangles can be congruent, and triangles are just triangles. Not only that, we learned how to do that with side, angle, side, 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 angle, side, angle, CPCTC. And now we are going to look at angle side theorems. But it's not like ASA, SSS, SAA. It's not that. This time, this doesn't really have a name. This theorem is a bit different. Okay, so if two sides of a triangle are congruent, then the opposite sides also must be congruent. So technically what this is saying is right here are congruent segments or congruent sides. I'm going to give it some names. I'm going to name this top one A, this one to the right B, and this one C. So now we can make a statement saying that CA as a segment is going to be congruent with AB. So if we understand that statement, then we can say that angle C can be congruent with angle B, because these two indicators are also saying that these two angles are going to be congruent with each other. If I draw arrows, when the theorem says the word opposite right here, that's saying this is going to be opposite to this, and that is going to be opposite to that. So it kind of crisscrosses. So if segment CA is congruent to AB, then we can say that angle C is congruent to angle B. If you don't like it in this form of equation, then there's an easy way for us to say it. Instead of long proofs like CPCTC or two congruent angles can bring you blah blah blah, we can say if the triangles have segments that are congruent, this is the actual symbol, then we can say that the triangles must have congruent angles. So here is theorem number 1. There's no official name for it, but this is how we can say it in our proof. If two sides of a triangle are congruent, then the opposite sides must be congruent. However, there is something similar like to this, but instead of saying sides, we now say angles first. So theorem number 2. If two angles of a triangle are congruent, the opposite sides also must be congruent. Here's an example. So here's what looks like a triangle. We have two angles. We have angle C is going to be congruent with angle B. But then the story gets more crazy. We can say that these two are now congruent. It's the opposite effect of this one right here, where we say sides before angles, but now we say angles before sides. So now we can say that if angle C and angle B are congruent, then we can say, no, not an angle. We can say segment CA is congruent with segment BA. So this is an express strategy, an express proof to understand if there are angles or segments that are congruent to each other in a triangle. There's one more thing that we sort of have to look at before we start doing our proofs to prove it. We can say this in a proof if there's a triangle with congruent angles, then we can say there's a triangle with congruent segments. That's how we can say it in a proof. This one cancels out both of the effects because it's saying with the opposites Theorem number 3. If two sides or angles are not congruent, then the opposite sides or angles are also not congruent either. So in this case scenario, I'm going to draw what looks like a triangle that is have equal sides, but actually it doesn't. So right here, there are no congruent sides. There are no congruent angles. If I try to match up the opposite sides with the opposite angles, this tiny one right here, this one's going to approach this one. This red one, this giant one right here, is going to approach the one right here. And this really big one, we're going to say in purple, we're going to put here and bring all the way there. So this is going to be the purple line that indicates each other. This one's going to be the red line that indicates each other. And this is going to be the orange line, the opposite angle. So orange is there, orange is there. Red is there, red is there. Purple is there, purple is there. Let's do another example. Okay, so we're going to mark this color in orange right here. So where do you think that points to? It points to over here. Now, what about red? Red's going to be right here. Where does that point to? Yes, it's going to point to the opposite over here. And the last color is purple. And where do you think that's going to point? The opposite. Correct. Up to the top, towards the sky. So, in this theorem, there are no ways we can prove that angles and segments can be congruent to each other if we can't prove that there's nothing congruent around here. Nothing to see here, nothing that's congruent. So now, let's look at our proof. Okay, so here's our proof. Given segment AB is congruent to segment AC. So AB is congruent to AC. AD is the median of BC. So when there's a median, that is right here. And we have to prove that angle B and angle C are with each other. So there's one thing that we're going to look at is, here is our givens, what was literally given to the problem. Here's the statement and the reason. Let's get started. So we know that AD is the median of BC. That can cause us to say that BD and DC are congruent. So BD is congruent with DC. And the reason why we can say is median can bring us a midpoint, which can bring us two congruent segments. Sometimes your math teacher wants you to leave it as this, and then you explain that D is a midpoint. Sometimes your teacher wants you to ask you that, and explain it right here, and split the two. But before we get advancing, there is one little shortcut. You could use SAS or SSS using reflexive and corresponding parts that are congruent can be triangles are congruent. But there's a speedy way and we can get to our answer and prove it without taking so long. Didn't you notice that there are two line segments that are congruent to each other? And from the video earlier, from the earlier part of this video, we said that there's a theorem saying if triangles have congruent segments, then it can bring us to triangles that have congruent angles. We can now say angle B and angle C are going to be congruent because of that theorem. Angle side theorem. So, in mathematics, One of the goals is to solve problems, but solving problems in an efficient way, and also learning how many we can solve problems. There are many ways to solve a problem, but some may be more efficient than others. We could do SAS or SSS, and then do CPCTC, but that would take a lot longer than just saying this. Now we have proven that angle B is congruent to angle C. And we are done, and we have now proved it. We have now learned all about the angle side theorem. I hope this video has helped you understand the angle side theorem. I hope this video... Thank you for watching Top Realized Math Industry. Like and subscribe.